Okay, it's time for us to have a look at odd and even functions. A very nice little area of the course. So I hope you get it after I show it to you. I'm sure you're going to like it. For even functions, these are symmetrical about the y-axis. In other words, the y-axis is the mirror. Okay? The mirror for the mirror images. The y-axis is the axis of symmetry, and the y-axis is the axis of symmetry, and here we have two very fine examples of even functions. This is f1 of x, as I've called it, and it's x squared plus 2. Can you see that the y-axis acts like a mirror? It's exactly the same to the right and to the left, okay? If this is the mirror. There's another example. f2 of x in this case is cos x, a trig function. Nice and even, I'm sure you'll agree. Now, algebraically, ladies and gentlemen, for an even function, f of minus x equals f of x. Now, you do need to know this as well. This needs to be firmly planted in your mathematical BIOS. Is that right? Is it correct? Well, let's have a little looky and see whether it is. Well, here's x on this side of the y-axis, and minus x is exactly the same distance the other side of the y-axis, and I'm sure you'll agree that the y values are exactly the same for x as they are for minus x for this function here and for the trig function below. So you see, f of x equals f of minus x. That is the characteristic of an even function. There's another even function for us, that is a truncus, 1 over x squared. A beautiful example of an even function. You can see it's even, can't you, now that I've showed you. Alright, let's move on. We'll go to odd functions now. Odd functions are very different from evens. They are produced by reflecting a function firstly about the y-axis and then about the x-axis. Now that rather does your head in, doesn't it? But I will show you what I mean. Algebraically, it's also very important to understand that for an odd function, f of minus x is actually the negative of f of x. In other words, these functions are upsy-downsy. Okay, I'll show you what I mean. Look, this is, what is it? X times bracket x plus 1 times bracket x minus 1, and you can see that it's sort of like the left-hand side, if we consider the left of the y-axis, is sort of like a upsy-downsy mirror image, if you like, of the right-hand side. You see, now, just go with me. Look, if we reflected that right-hand bit about the y-axis, and then we reflected it about the x-axis, you would get that, yeah? Can you see that? Yeah, it's pretty obvious once you really think about it. But they're really upsy-downsy mirror images, okay? This is whatever's down here, this far to the right of the y-axis is exactly the same distance up, the same distance to the left of the y-axis, if you know what I mean. So whatever's down here is up there, whatever is up there is down there. Same thing applies to this red function here, which is sine x. How marvellous. You getting me? So that is an odd function. F of minus x is the negative or minus f of x. Yeah. There's another example. That's a rectangular hyperbola. That is 1 over x. Yes. What a fine example it is too. Now, what do we have to do here? We have to write out the equation and draw the graph of an odd function and an even function. Wow, look, that's pretty easy, isn't it? I hope they ask us that in the exam. So if y equals x, that's a beautiful example, even if I do say so myself. That is odd, isn't it? It is odd. And this one here, we've got y is minus x squared. Yeah, that's a beautiful little even function, isn't it? Very, very nice. Is that all we had to do? Yes, that was pretty easy, wasn't it? So, to summarise, ladies and gentlemen, odd functions have the property that f of minus x is minus f of x, and even functions have the property that f of minus x equals f of x, okay? This means that on either side of the y-axis they are symmetric, yeah? And these are sort of like upsy-downsy symmetric, not really symmetric, but you know what I mean. Yes, okie dokie, let's go on. Okay, example 2, we have to state whether each of these functions is even or odd or neither. Very interesting. Let's have a look. What about A? What do you think? I think that's a definite even function. Some of these you can work out just intuitively. Some of them it's a little bit harder, but you can always apply the algebraic test, which I'm about to show you. Okay. Alright, so this one here, I'm saying that's even, because I can picture it in my head. Absolutely dead set even. But let's do the algebra. Okay, if x equals, say, a value a, then y would be a squared plus 1, yeah? But if x is minus a, then y would be minus a all squared, becomes just a squared plus 1, which is the same thing, you see? So what we're saying is that y of a is the same as y of minus a, which means, it is even. Yes, it is. Pretty cool, huh? Very cool. Now, B, for you and me, this looks pretty yucky, doesn't it? However, ladies and gentlemen, to the trained eye, I can predict that this is even. And do you know how? Because I'm breaking this up into component bits in my head. I'm saying, okay, x to the 4 is a quartic, which is even. Yeah? And if I was to add to that minus x squared plus 1, which is just an upside down quadratic moved up 1 from the origin, that's also even. So if that's even and I add another even function to it, like addition of ordinates, yeah, adding two y values together for every given x value, in other words, I would still get an even function. But let's just check it out. I think that will be the end result though. Okay, if x is minus a, y is going to be that. And if x is plus a, y is exactly the same thing, isn't it? Yeah, see? Very cool. So therefore it is an even function, as we predicted. What about C? What do you think? I think, no, I don't think that's anything. I think that's a neither. See, this here, if you just had this, the x cubed bit, that would be odd. But if you add 5 to it, in other words, translate the whole thing up 5 units, I think you mess everything up. It's not going to be odd at all. No, no, no. So I think that's a neither. Let's just put it to the test, guys. There it is. Now, if x is a, we get y is a cubed plus 5. If x is minus a, y is minus a cubed plus 5. So therefore, no, well that's not odd. And it's not even. There's the even test. It's not even. And it's also not odd. So it's neither. See, we were right, weren't we? Great. Now, let's go for D now. A rectangular hyperbola. 2 over x minus 1. So it's shifted over 1 to the right, and there's a dilation happening there. But I don't think that's going to be in anything, ladies and gentlemen. I don't think so. Let's just work it out. If x is a, y would be 2 over a minus 1. If x was minus a, y would be 2 over minus a minus 1. So, yeah, that's right. That's what that simplifies to. So therefore, y of a is not equal to y of minus a. So it's certainly not even. We weren't expecting it to be anyway, really. And also, we know we can see that y of a is not equal to minus y of minus a. No, it's not. Have a close look and prove that to yourself. You see, there's y of a, and there's y of minus a, which is not the negative of this one. It is not. Okay? So, we were right again. It's neither. Yeah? You're getting the hang of this now? Good on you. Aha! I can see an odd function, if ever I saw one. That's a cubic, and let's just go through the motions. If x is a, y is a cubed. If x is minus a, y is minus a cubed. Therefore, we know absolutely for sure that that's odd. No problem. Let's have a look at the last one now and finish off with a bang, shall we? What do you think? Come on, make a prediction. Well, I know this bit of it's odd, and I know that bit of it's odd. So I'm saying the combined x cubed minus 4x as a total function, if you like, after adding the ordinates, graphically, you'd certainly get odd, I think. Let's go for it. Y is x cubed minus 4x. And aha, it's odd. No problem, it's odd, yeah? Wasn't that fun? Okay, now you know about odd and even functions, so let's go forth and conquer some more.